Hello everyone, so in this video I want to look at an example about Lewis acids and bases. So this example is going to look at how can we identify and define some substances as either a Lewis acid or Lewis base. So let's just remind ourselves on what the definition says, whether or not something is a Lewis acid or a Lewis base. So a Lewis acid is a species that can accept electrons, right? It's an electron acceptor. And a Lewis base is a species that can donate electrons, right? So that's what we're looking for. Something that can either, if it can accept electrons or mainly accept electrons, that means it is a Lewis acid. If it's something that will donate electrons predominantly, it's a Lewis base. Right, so our first species is iron 2+. And if we think about how iron 2+ comes about, iron 2+ is an ion, which comes about because iron lost 2 electrons. In other words, Fe2+ is electron poorer than what iron, just the pure metal, is. And hence, it is a species that wants to accept electrons, right? So that makes it a Lewis acid. And why? Because it is an electron acceptor. Because when it wants to form a bond or want to do anything, it's going to want to accept electrons or electron density to form that bond because it's electron poor. Right. I mean, you can see that because it lost its electrons somewhere along the way, and now wants to gain electron density again to form a bond. All right. If we look at B, we need to remind ourselves on how amines work, or anything containing nitrogen. That's what I want to zoom in on here. So C3NH2, we must remember that nitrogen will be carrying a lone pair. And anytime that you see that, that means that this thing must be a Lewis base. Why? Because it would be able to be an electron donor. And it's an electron donor through that lone pair that it has. So that lone pair can easily donate electrons. All right. Now, boron trichloride in C is an interesting case. And hopefully what you do remember from boron trichloride is that it has an empty space on the central atom here. So meaning it does not fill, if you draw the Lewis structure of boron trichloride, if you actually draw out the Lewis structure, Lewis line structure, you will notice that boron only forms 3 bonds, and that boron does not have a lone pair to complete its octet. It actually only has 6 valence electrons, which means that there is an empty orbital on boron. And hence, that means that that empty orbital makes boron electron poor. And when something is electron poor, it means that it can be an electron pair acceptor, making it a Lewis acid. Right, it's an electron acceptor. You can go into details on what exactly which orbitals those are, but there is an empty space because boron does not have a filled octet on it. Or at least for your purposes, that's what the explanation is. So that makes it a Lewis acid. Hydrazine, looking at it, so hydrazine, there's nitrogen present in hydrazine. So once again, I mean, just looking at, I mean, either of those nitrogens, so NH2, either of those nitrogens have lone pairs on them, and because they have lone pairs on them, makes them Lewis bases, or makes it a Lewis base, because it can act as an electron donor. Right, and then finally we're given a reaction where we actually need to investigate what happens in this reaction. And again, we see we have a metal, we have silver, we have the silver ion, and we have NH3. And we're asked to identify which one is the Lewis acid and which one is the Lewis base. And this is a perfect example to see, well, the ammonia has a lone pair on it, and the silver is electron poor. And this is where the ammonia donates its lone pair, so it acts as the electron donor, so meaning it is acting as the Lewis base to form a bond with the silver, which is then hence the Lewis acid, because the Lewis acid is accepting the electrons from the ammonia to form a chemical bond, right? And hence we get a species which is called a coordination complex, which is then formed there as the reaction states or gives. Alright, so you can see that's just the basic definitions of Lewis acids and bases. Nothing too intense. Actually, just to remember, Lewis bases are electron donors and Lewis acids are electron acceptors. Alright, so yeah, that was the point of this example. Specifically, things to look out for: empty orbitals, charges, and of course nitrogen, always something that's able to donate electrons. Anything that has a lone pair in general will act as a Lewis base because it can donate that lone pair. Alright, thank you for watching, and I'll see you in the next video.